Hello, calculus. We have two more. I'm calling them interesting and challenging integration by parts problems. I will start this video by just saying these two problems that we're going to do are a little bit more challenging than I'm probably going to expect you to do on a quiz, but it still is really good for us to practice something that's a little harder. And so please stay with me as we try these two problems. So we look at this first one, the integral of e to the x times sine of x, all with respect to x. And as always, for an integration by parts problem, we have to first decide what is our u going to be. So we consider Liate, which would say logs. No, there's no logs in here. Inverse trig, nope. Algebraic, nope. T trig. So that means in this case, our u would be sine of x, and our dv is everything else, or e to the x dx. All right, we've got our u and our dv, which means we can take our derivative of u. The derivative of sine, when we sin, there's a consequence. So cosine of x dx, and the antiderivative of e to the x is just e to the x. We have all our pieces we need, so we have the integral of u dv is equal to u times v minus the integral of v du. And we get to put everything together. So we have this guy right here. This is, again, what we are starting with. And this is going to be equal to u, which is sine of x, times v e to the x minus the integral of v e to the x times du times cosine of x dx. And I look at this and I say to myself, okay, normally this thing right here should be easier and that we should take an antiderivative really quickly. But I'm looking at this and I'm thinking, wait, this is not really that much easier. And so, unfortunately, we need to do it again. So, another integration by parts. All right, so just scroll for a moment. We look at this. Now I'm really just going to focus on this piece right here, and I'm going to do all my integration by parts again. So Liate would tell me logs, nope. Inverse trig, nope. Algebraic, nope. That means my new u is going to be cosine of x, and my new dv is e to the x dx. The derivative of cosine is negative sine of x dx, and the antiderivative of e to the x is just e to the x. All right. Okay, sorry, I just resituated the screen a little bit. All right, so we have our u, we have our v, we have our du and dv, which means I can now do my second integration by parts. I'm going to start just by writing what we had at the beginning, right? We're not losing that. So we have e to the x times sine of x minus, and I'm going to put this in big brackets just to say we are now doing this second integration by parts using this piece. So u cosine of x times v e to the x minus the integral of v e to the x times du, negative sine of x dx. Okay, maybe you're thinking like, oh no, this doesn't look much better, and you're kind of right, but guess what? It's going to be okay. So now let's simplify what we can. So we still bring this down. We have e to the x times sine of x, and I have minus, and I'm going to distribute that. Actually, I'm going to write it as minus e to the x times cosine of x. Now stay with me because this is going to be, it's not really a lot, but just pay attention. So technically I'm distributing this negative. Okay, so this is becoming a positive, but I have this negative right here, so I'm actually subtracting the integral of e to the x times sine of x dx. If you need to think that through again, please do. Again, I'm distributing this negative to both pieces, making this a positive, but then I have this negative inside, which makes it negative again. Okay, so here's what we got. And maybe you're like, shoot, Miss Wissing, we have to do it again. Integration by parts one more time. But here's the good news, or kind of good news. What we have here, what we are left with, this is what we originally started with. This was our starting point, right? Right at the beginning, I asked you to find the integral of e to the x times sine of x all with respect to x. That's what we have right now, okay? So what does this mean? Well, let's write this all out. Again, the start, let's call our beginning, I'm going to say a is our original thing, e to the x times sine of x with respect to x. This is just going to help us. And at the beginning, we are asked to find the integral of this thing. On the left side here, we're all finding this. This is our original. Then we calculated these pieces. We know it's e to the x times sine of x minus e to the x times cosine of x minus, and look, again, this is where we started, so I'm going to say minus a, what we started with. We are still solving for a. We still want to know what is this integral, okay? So if this were an equation, if this was x is equal to 4 plus 3 minus x, well, you guys know how to solve that. We'd move the x to the other side and simplify. We're going to do the same thing here. So I'm going to move my a over, and I really would get 2a is equal to e to the x times sine of x minus e to the x times cosine of x. All right. Again, we're still solving for a. We want a all by itself. How do I get a all by itself? Well, I divide by 2. Or my final answer is equal to 1/2 times e to the x sine of x minus e to the x times cosine of x, and then technically we need that plus c. Remember, dividing by 2 is the same as multiplying by 1/2. That's why I wrote it like that. It just looks a little nicer. And we've got our answer. All right, we got one more problem. I am going to warn you, this one is not necessarily super challenging. It just has a lot of little pieces and it's kind of easy to get lost. So I'm going to try and do this in the best way I can, and I'm going to try and use a lot of different colors to help distinguish what is going on. I would also like to start this problem by saying, again, you're not going to be asked to do something like this on a test or a quiz. It's just a really good problem to think through. It practices both u substitution and integration by parts. And last but not least, you probably need a bit of inspiration to start it. So I think it's probably a good idea that we're doing this one together. Okay, here is our problem. The antiderivative of x cubed all over x squared plus 2 quantity squared. Now, in order to do this, I am going to break this function up to look like this. I'm going to write it as x squared times x over x squared plus 2 squared, all again with respect to x. Now notice all I've really done is pulled out an x squared from this x cubed. I haven't really done anything different. And again, like I said, this would be something that I'm kind of giving it to you this time because it's probably a step up from what I'm expecting you to do at home on your own. That is okay though. So we look at this and we then are going to choose our u to be x squared and our dv to be everything else. X over x squared plus 2 quantity squared dx. Then so we can take du, that's easy, just 2x dx. But here's the challenge. Calculating this antiderivative seems really hard, right? And technically v is the integral of x over x squared plus 2 quantity squared dx. And that, my dear friends, is not so easy. But guess what? We can still do it. It's just going to be a little challenging. That's okay though. This we are going to solve using u substitution. All right, I paused the video to kind of situate things a little bit. And let's get back to it. All right, we are going to take this antiderivative right here using u substitution. Why is my pen? Okay. So I'm going to select my u to be x squared plus 2. Why? Because then du is 2x dx, which is going to cancel out this x in the top. All right, I'm going to substitute things in, so I technically have the integral of x over u squared times du over 2x. This is great because our x's are going to cancel, and I am left with the integral of, well, I'm going to pull the 1/2 out front. So this 1/2 right here comes out front. And I have u to the -2. I moved it up, du. Okay, that we can take an antiderivative of. We are definitely smart enough for this. So this is really -1/2 u to the -1. All right, add 1 and bring that out front. And we substitute back in, so I have -1/2. U was x squared plus 2 to the -1. And now we have to think back to why we were doing this. What was this? This was our v. Okay, again, I made it smaller. Definitely pause the video if you need. But this was our v. So we now know that v is equal to -1 over 2x squared plus 2. All right, that's this thing right here. I just kind of rearranged it. So now, back to this guy, we have uv minus the integral of v du. We have all of our pieces. We can put them all together. So we have u, which was x squared, v, which was the -1 over 2x squared plus 2, uv minus the integral of v, -1 over 2x squared plus 2 times du, which is 2x dx. Okay, let's make this a little nicer. Oops. I'm going to make this look like -x squared over 2 times the quantity x squared plus 2. All right. I am going to pull this negative out. All right, so we technically have plus, and I'm going to cancel these 2's. So we have the integral of x over x squared plus 2, all with respect to x. And now, again, we're stuck, right? We have a little bit more to do, but I can solve this integral using u substitution again. Yay. I know you're so excited. I can feel it through my computer screen. All right, so this first part does not change. I have -x. Actually, I'm not even going to write that yet. Let's just do this u sub first, and then we can go back. All right, so to solve this integral right here, I'm going to say u is x squared plus 2, which means the derivative of u is 2x dx. So I can substitute things in. I really have the integral of x over u times du over 2x. Right, I solved this. I moved the 2x over. So what can I cancel? I can cancel my x's. I can bring the 1/2 out front. So I have 1/2 the integral of u to the -1 du. That's not bad. That's not bad at all. Or I really have 1/2 natural log of u, technically, plus c. Remember our u was, what was our u again? Oh, x squared plus 2. I have a plus c. And now I'm going to come, oh goodness, I'm so sorry. Hold on. I'm going to pause it and resituate. All right, I just made it so I could see everything on the same screen. Remember, all that work we just did was taking the antiderivative of this red piece. Okay, so technically we have all of this. We still have plus. And so we can't forget to bring down that piece. So negative x squared, negative x squared over 2 times the quantity x squared plus 2. And that, my dear calculus friends, is our solution. Maybe a bit more work than you were hoping for. As I said at the beginning of this video, both of these problems are more challenging than I would expect you to do on a quiz, on a test at this point, because honestly, you're at home, you're alone, you're not being able to ask questions as easily as in class, so don't stress if this was a little bit more challenging, but I wanted to give you something, honestly, that was harder than what we've been doing. So I hope you have a lovely day, whatever it is that day entails. Please reach out if you have questions, if you just want to chat. I miss you all so very much, and I will talk to you soon.